Hey, what's up guys? My name is Cherno. Welcome back to my game engine series. So last time we talked about logging and we actually added a logging library called spdlog or speedlog. Video to that is linked up there. Make sure you watch that before you watch this video. Today we're going to be finally using a build system of sorts. So basically we're going to be using some kind of project generation kind of library, I guess, or program that just generates projects for us. This is something that we haven't done as of yet. There's been kind of discussion of using maybe CMake or something like that. Because we kind of have this problem of we need to generate projects, and we're going to talk a little bit about what that problem actually is today, as well as we're going to solve that problem as well. So first of all, project generation, like why do we need that? Why can't we just, use Visual Studio and make our projects and everything's going to be fine? So we can, and that's what we kind of have been doing up until now, but the big issue kind of creeps up when we have to deal with different platforms. So what I mean by that is, right now, our build kind of tool set is Visual Studio on Windows, and that's it. So the only kind of project files we have to deal with is Visual Studio, right? We have solution files, we have VCX proj files, which are the C++ project files. All of that stuff is kind of Windows, I guess, the Windows environment for the Hazel engine, right? But as soon as we start to kind of add other platforms, like for example, Mac or Linux, or even like Android or iOS, right? We need to actually generate project files for our engine that can be used with a tool set that will compile those applications for us, right? So what I mean by that is, like, we literally need to generate, for example, an Xcode project file so that we can build this for iOS. That's one example, right? I mean, we don't have to use Xcode on Mac to build for Mac, but supposedly, like, let's just say that we do, right? So we need to generate Xcode project files so that we can build this Hazel engine on Mac. What about Linux, right? We might want to generate some kind of project files for a specific IDE, or just make files, or something like that. But the idea is we have our Hazel project, right? But the way that we've defined what that project is right now is just through Visual Studio. We've just said, okay, these are all of the files that go into this project. These are all of the defines I'm going to need. For example, A to Z platform Windows, if we're on Windows, right? I've defined what my project actually is, right? But I've done that in Visual Studio. And what we need to do is, instead of do that in Visual Studio, we need to kind of define what our project actually is, what the Hazel engine actually is, in some kind of other format that can then be used to construct platform-specific project files, or rather maybe even toolset-specific project files, okay? So what we're going to be using for that is something called Premake. I'll have a link in the description of this video to what that actually is and the GitHub repository so that you can read about it. The wiki they have is fantastic for learning kind of about what Premake actually is and what it can do for you. I didn't want to use CMake because I don't personally like CMake. I think it's very complicated. I think it's very kind of, it uses its own kind of format for a lot of things, and it's just unnecessarily complicated and hard to deal with. Whereas Premake is written in Lua, or rather, like, when you write Premake files, you write them in Lua, and it's just really easy to use. There's not much to it. I mean, we're gonna write a complete Premake kind of file, I guess, for the entire Hazel engine right now. It's going to be really simple. It's easy to understand for people who are new to this, and it's very powerful, and it can generate project files for everything that we need. Okay, so that's the idea. And then once we kind of define in kind of Premake's format, once we define that in that arbitrary format, we kind of define what Hazel actually is. So for example, these are the C++ files we need to include. These are the header files we need to include. These are the include directories. These are the libraries we want to link. These are the defines that we want to use. These are the different platforms or configurations we want to set up, right? Once we define that in Lua, we can then just run Premake, and it will generate Visual Studio project files for us, or Xcode project files for us, or Make files for us, or whatever, right? So that's kind of the idea of why we want to use this kind of project generator rather than just deal with everything manually. Because as you can also imagine, we could maintain everything manually. We could make Xcode project files, Visual Studio project files. Every time we add a new file, we add it to both Mac and Windows, but we'll have to do that all kind of manually, and that's just a pain. This is much, much easier. And we'll even make like a bat file, which will just be like on different platforms it will be different, but since we're sticking with Windows for now, it'll be a bat file that we can just double click and it will just generate everything for us in, like, I don't know, probably take like 100 milliseconds or less. So it's going to be fantastic. So without further ado, let's just jump in and set up Hazel with Premake. Okay, so the first thing I want to do is actually just kind of run this maybe and just see what we actually get, just so that we have like a result that we can kind of work towards. So I'll just wait for this to compile and run. And there we go. So we see that we initialize log and we just print hello, and then we have a while true loop. Okay, great. So that's kind of what the Hazel engine is at this moment. So now let's take a look at Premake. So I'll have a link to this in the description below. But Premake is essentially available free on GitHub. If you look at the license that it actually comes with, it basically just says that it's free for pretty much everything, just as long as this copyright notice is actually retained. So we'll have to actually kind of download this license text file and use it. So I will definitely save that somewhere. But otherwise, we can just go to releases. And then Premake 5.0 Alpha 13 is what we're going to use as of this point. I suspect that as Premake comes out with new releases, we will simply grab that. We'll definitely be using Premake 5 and not Premake 4. Even though this is kind of still an alpha, it's still quite stable. And it's been fine in my experience. And it has a lot of features that I actually want to use. So there's the Windows zip file. I'm just going to download that. And then that should be nice and simple. I think that will only have an exe file and that's it. So if I copy that exe file, I'm going to go into my Hazel directory. I'm going to make a new folder called vendor. So this vendor folder is different than the vendor we have in Hazel because this vendor folder kind of applies to everything. Whereas this vendor folder in Hazel is just kind of stuff that Hazel needs that isn't ours. This is stuff that the entire solution kind of needs that isn't ours. And inside vendor, I'll make a directory called bin and I'll paste in premake5.exe. I could even kind of make, maybe I'll make a folder called Premake or something like that. Put Premake 5 in there because I also have to retain this license file. So if I just hit raw, I'm going to right click save as, and then save that license.txt file in here. Okay, so now I am, of course, in our actual repository, which we will commit. We have Premake 5exe as well as that license file. Okay, great. So there we go. Premake is now in here. All we need is a binary. We don't need to compile it ourselves or do anything like that. That's really all that we need to do. Now we just need to create a file that basically just tells Premake what this whole Hazel project is, so that Premake can then generate, the solution files, this Sandbox VCX proj file, this Hazel VCX proj file, anything that our project actually needs, it will be able to generate. So as for a guide to how to do that, again, this is not intended to be a Premake tutorial, but inside the wiki here, so in the Premake repository, they have a fantastic wiki, which you can see has like just a bunch of stuff, including this kind of great guide to your first script. So they actually write like a C file here, just a little C program that just outputs hello world, and then a Premake script, as they call it, which is just premake5.lua. You can see it's the name of the file that basically just says how exactly to define something as simple as that. And you can see what this does is Workspace just basically means solution for Visual Studio. So we're creating a solution called Hello World with 2 configurations, debug release. Then we're creating an actual project. So this will be like a C/C++ project in this case, called Hello World, which will be a console app, which means it's an executable. There's a target directory, which is where the files will be built to, which files should be included in the project. So basically anything in kind of child directories recursively that have header files or C files. And then we can apply certain settings to specific filters. So for just the debug configuration, we're going to apply debug, for example, and debug symbols will be turned on. But for release, we'll have ndebug defined and optimization turned on. So that's kind of just a really basic example of how Premake's going to work. Again, I suggest you read this. Maybe in the future I'll come up with a more detailed Premake tutorial, but of course in this case this is more or less just using Premake in Hazel, and that's what we want to achieve right now. So popping over to our Hazel directory, I'm going to right click, hit new, and then create a new text document, which is going to be called premake5.lua, okay, which is, as you can see, the same format that they've kind of done here, right? And then I'm not really going to copy a lot of this, I think. I'm just going to type it out myself. But we're basically just going to make, I'll drag this premake5.lua file into Visual Studio, and we're basically just going to make our Premake file here. So Workspace, of course, I'm going to call Hazel, okay? So this Hazel Workspace is kind of this solution. You can see it's called Hazel, that's what it's going to be. The architecture for this is going to be x64, okay? I seem to be struggling with quotes here. Basically, the architecture is just the platform that we actually want to deal with, which in this case, we have decided we don't want to deal with 32-bit right now, just x64 and that's it. And then for the configurations of this, you can see that we've kind of got debug and release, which is the default for now, but I am actually going to add a third one. So we'll have our configurations. We're going to have debug, which of course is just the debug configuration that we are used to, the release one, and then I'm also going to add something called dist. So we might talk about these three in the future. You'll kind of see how they work maybe in here as well, but debug is basically just full-on just debug code, everything enabled that we kind of use to develop. In release is kind of not necessarily the release mode that we kind of, or the release build that we actually send out to people, but it's just kind of debug, but with a lot of debug information stripped, optimizations turned on, but other things such as logging, for example, still actually enabled. So it's like a faster version of debug, essentially, that will also do less. And then distribution is actually everything kind of stripped, everything, just our complete distribution build with absolutely no logging or anything like that. That's kind of the idea. And we'll of course see how this works in the future of this series. And then after that, I actually want to create a project called Hazel. So this project is kind of corresponding, because it's called a project and not a workspace, it's kind of corresponding to this Hazel project. So basically stuff that we've put in here into properties such as, you know, our preprocessor, stuff which you can see is HZ platform Windows, HZ build, DLL, Win, DLL, you know, I'll copy these right now. But, you know, stuff like that, as well as all the files it includes, that's kind of what we actually want to put into here, because this is our project. So what I'll do is, first of all, specify the location of this. So we want it to kind of, our Premake file is inside our Hazel root directory, but you can see the Hazel project is inside a Hazel folder. So to kind of specify that, I'm going to type in location Hazel, and that'll make sure that everything will be relative to this path, as well as everything that we, like the project files we generate, will actually be placed into that path. You can see we of course want these VCX proj files to be inside Hazel and not alongside our solution file. Now I need to set the kind that it is. So basically, is it like an application executable? Is it just a static library? Is it a dynamic library? Because it's a dynamic library, we're going to say that it's a shared lib, because that's the correct way to specify that it's a DLL file. Inside Premake, shared library is the same as a dynamic library. And then the language we're going to specify is C++. Okay, cool. So now we need to specify like a target directory, essentially. So where is this going to be output to? You can see we kind of want it to be bin, and then debug x64, and then the project name and all of that. So that's basically what we're setting up here. So it's going to be bin. And then what I'm actually going to do is, because we'll have to reuse this a bunch of times, I'm actually going to create a variable here called output directory, right? Which will basically use a bunch of kind of tokens that Premake supplies us with. I don't know if there's a good page. Well, there definitely is a good page on tokens, which basically just specifies a bunch of macros, so to speak, that you can actually use. So stuff like the configuration name, the file like name, the target path, the workspace location, all of that stuff you can kind of use as macros, the same way that we kind of have done inside Visual Studio, where we've actually used, you know, the solution directory or the platform or the configuration, that kind of stuff, right? So what I'm going to do is just kind of construct my output directory based off of those things. So the first one that we're going to use here is going to be the build configuration. So this will basically be whether or not it's debug or release. Then I want to include the system, right? So configuration.system. And then I'm going to also have the architecture. So this is a little bit different than what we actually had, because the system is going to basically say whether or not it's Windows or Mac or something like that, right? Because if we just have kind of debug x64, well, that could be on Mac, right? And since we're kind of trying to make this be universal, like basically be cross-platform, we actually need to have multiple kind of system support, I guess, so that we actually differentiate between stuff like that. So configuration architecture, okay? And that will generate something like debug Windows x64, which is what we need. And then we'll take that and we'll append it to this, like that. And then we'll also continue here because we now need the actual project name. So slash, and then prj.name, okay? And that is it. So we're putting everything in bin, and then like debug Windows x64, and then Hazel. That will be the kind of output directory for our binaries. And now we need to do the same thing, but as we did for bin int, which is our kind of intermediates. So the way that we specify that is basically by just writing obj directory, right? And that'll be bin hyphen int. I think someone asked why I called this folder bin int and not something like obj, like obj, right? The reason I did that, well, one of the reasons was that they're nicely grouped up here. So if I want to delete these or whatever, they're just right there, bin int, that's it. If I had obj, it would be sorted somewhere below, you know, Hazel in this case, and it'll just be a little bit less kind of grouped together and a little bit less clean. So that's why I prefer to do it this way. Okay, and now we can define the files that we actually want to include inside here. So I'll say files, and then we'll basically just have a list of files that we want. Now, everything, of course, is kind of inside the project name, right? So the project name is Hazel, which happens to be the location here. So what I'll do is I'll say that these files are kind of inside project name, and then /source, and then we'll do a double star, which basically means recursively search the folders from that folder kind of downwards, right? All of the child folders, .h, right? So H files and CPP files. Now, if we have like HPP files or .c files, that's something that we also might include, but since we don't have any of that right now, I'm not going to worry about that. Just basically every .h file and every .cpp file that is inside the source directory should be included inside here, okay? And now I'll also do the include directories. So I think the include directories that we actually ended up using were really just spd log, right? So that's what I'll do for now. This will simply just kind of be, I think we had a specific one though. Let's just copy it. So Hazel vendor, Hazel we can keep, and then just vendor spd log include. Okay, sure. So I will say, over here, we'll grab the project name, slash, just, I guess project name, slash vendor, because it's not in source. So project name, vendor, spd log include, that should be correct because we should be in Hazel vendor, Hazel vendor, and then spd log include. Okay, great. Cool. So there we go. That will be our kind of sole include directory for now. But if we decide to include other things, obviously as we go along, we will just add it to this list. Okay, so now we can talk about kind of these Defiance. Now, these are obviously Windows-specific Defiance, so this is a good time to actually introduce filters. So we can use filters to say that we have certain project kind of configurations or other certain kind of project properties that we only want to apply to like a certain platform, for example. So in this case, we'll say if the system is Windows, then kind of everything else, everything underneath this filter. Tabs don't actually matter, by the way. Indentation doesn't matter at all. I'm just using it here so that it's more readable. But basically anything underneath this filter until we either reach another filter or another project or something only applies to Windows. So for Windows, we'll set our CPP dialect to C++17. The reason I'm setting this just for Windows, by the way, is because for other compiles, we actually might need to have like a specific compile flag rather than just being able to arbitrarily set the CPP dialect, because that's not kind of supported by Premake on all compilers. The static runtime will set to on, which kind of has to do with linking the runtime libraries. We want to obviously link them statically in this case. And then what I'll do is I'll actually create something called system version here. Now, what I'm going to do for this is I'm just going to copy the version that we have up here, the Windows SDK version, and just paste it in here. The reason that we need to do this is because if you don't specify this at all, then Premake will actually generate a Windows 8.1 Windows SDK version, right? Which not everyone has installed. For example, I didn't actually have this installed on my laptop, and so I had to manually retarget the solution. That's annoying. So we'll just go with this. We might, if there was a way to just change it to like 10.x or just to use latest, I would do that, but I don't think there's a way. So for now, we're just gonna leave it on just the version that I happen to have installed on my computer, just like that. And now finally, we can talk about the Defiance. So these are our three Defiance. Let's copy them, paste them into here. HZ platform Windows, HZ build DLL, and this kind of win DLL as well, which we probably aren't using anywhere. I would go as far as to say we probably don't need it. In fact, I might omit it for now. That's just something that was automatically generated by Visual Studio when we actually created a new kind of DLL project. I think, even though I think we did create an empty project. Not sure, but anyway, yeah, WinDLL, is that used anywhere? Let me just quickly check the entire solution. It's not, so I'm going to omit it for now, and we'll see if that breaks anything. Okay, and then finally what I want to do for Windows as well is kind of create a post-build step to Hazel that actually puts the DLL where we want it to be. Because you can see that every time we kind of built this, we had to manually copy the DLL file from Hazel into Sandbox. I don't really want to do that, so I'm just going to add a post-build command that actually does that. So the safest place to add it is actually as a post-build command to our actual Hazel project. Copy is a command that actually comes with Premake. They've got a few, I don't know if post-build command will actually be here. I guess it will. You can see that the wiki actually has an example of copying stuff. So that's basically what we're going to do. So we're going to type in copy, and then we'll copy from the configuration build target relative path, which is that, into /bin. So we're going up a directory into the bin folder, and then into the output directory variable, and then into /sandbox. Okay, so basically what this is going to do is just in Hazel, it's going to go to the bin directory and copy hazel.dll into Sandbox, into the Sandbox directory, so that we have it alongside there. Okay. Next, I'm going to go and create a filter that's going to be our configurations debug filter. Okay, so this filter will kind of only apply to our debug configuration. So what I want to do is define for the debug configuration hz_debug. Okay, and also we're going to have debug symbols turned on. I'll copy this and we'll kind of paste it 2 more times. For release, I'm going to use hz release, of course. Optimization will be turned on, so optimize on. And then this one will be our dist configuration, which will have hz dist defined, and then optimization on as well. So that's all we'll do for now to keep this nice and simple. Now, quick note, when you use a different filter like this, it actually is completely, it's only this. This isn't now Windows and debug, it's just debug. If you want to do both, then you have to specify both of the kind of filter options. So for example, what we'll do here is we'll set it to kind of use the multi-threaded library here. So we'll just say filters. You can see I've typed in filter, but I've actually opened up a curly bracket here because I'm specifying multiple options here. So we'll have, so basically for Windows and release, as an example, we're actually going to set, build options /mt, for example, which is basically the equivalent of just going over here into command line and then doing /mt, which in this case, it just tells us to use the multi-threaded runtime library as seen here, okay? But we won't worry about this for now. That's just an example that we might come back to in the future. Okay, cool. Anyway, that's it. So that is our entire Hazel kind of configuration right here. I think that's pretty simple. Hopefully it's fairly easy to understand. I think I explained it fairly comprehensively. I don't think there's much else I could really say. Apart from, if you don't understand any of it or some of it, then just refer to Premake and the wiki. And maybe just practice by creating your own C++ project and then using Premake to try and generate files from there. Okay, cool. So anyway, we now need to create a Sandbox project. It's going to be our Sandbox project. The location is going to be Sandbox. The kind is going to be console app this time instead of shared library. Language will still be C++. Let's just copy a bunch of these things. Really what I could do, by the way, is just copy like most of this, I think, because it's going to be fairly similar. So I'll copy all of this. So inside Sandbox, we have a console app. Language will be C++. And target directory will be the same because we've used kind of project name and macros like that. We can literally just copy and paste it and we don't need to change anything. Files will have, that'll be exactly the same. Include directories will be a little bit different. So we do still need that kind of SPD log include here, but what we actually can use, or rather what I will want to use, because I think we just include hazel.h here, kind of by a compiler include path, because we actually have, you can see Hazel source pointing here. So what I'll need to do is also add Hazel source as an include path here. Under filter system windows, this will basically be the same. Of course, we don't need the build DLL thing. HZ platform windows should still be defined. We don't need this post build command either. Configuration debug release and dist kind of remains exactly the same though. So one thing that we need to define here that we didn't do, of course, inside Hazel is the actual link. So Sandbox needs to link in Hazel, and all we need to do for that is just type in links and then the name of the project. So Hazel, and that is it. So you can see that Premake is quite easy and nice to use, and we really don't have anything too complicated, I don't think, here at all. Okay, that's it, we're done. So now what I'm going to do is a few things. First of all, in our Hazel directory, I'm actually going to delete bin and bin int, okay, because that's stuff that is a result of compilation, so obviously we should be able to regenerate that easily. I could also delete the Hazel solution file and also the project files and all of that stuff. I'm not going to bother because Premake will kind of regenerate that for us. So now all I really need to do is actually call Premake with this script file, and hopefully everything will work. So I'll open a command prompt in this directory. I'll type in, I think, vendor bin premake and premake5.exe, and then the project files that I want to generate for. So in other words, I want to generate Visual Studio 2017 project files, so I'll type in VS 2017. I'll hit enter and we'll see what happens. Okay, so we attempted to concatenate a table value. Fname, that's great. I probably just have like a syntax error or something like that, so I'll look through this quickly. So one problem that I spotted so far is that include should actually be include directories, so include dirs. So let's rerun that and see what happens. And there you go. So unfortunately, sometimes you don't get the best error messages, but checking over that seems to have fixed that. Okay, great. So in like 84 milliseconds, we regenerated all of our solutions. It's really nice and fast. And so what we have over here now is brand new kind of Hazel solution file. So to kind of further prove this point, I guess, what I'll do is I'll delete all of this, including the user kind of stuff that we have here. So we'll delete all of this. And then we'll just run this kind of Premake thing again. Now, instead of me having to every time open a command prompt and just type this stuff in here, what I'm actually going to do is make a bat file. So I'll make a new text document that's just going to be called generate projects.bat. I'll open this over here. I'll type in, oh, this has been all destroyed, hasn't it? Let's just close this. No, I don't want to save changes. Let's go back and open this. I'm just going to type in call and then this, so call that, and then probably just pause so that it doesn't close the window immediately. Okay, so now that I've done that, I should just be able to double click generate projects. You can see it generates everything for us. There's that new solution file. I'm just going to drag that into Visual Studio here to open the solution. And here we have, you know, Hazel with everything. You can see it even generated the right kind of filters for us. And you know, if we go into properties, for example, we should see the correct kind of output directory here, as well as, you know, like this kind of stuff that we've added, like our include directories and our defines are all there. And also you can see Sandbox references Hazel correctly, which looks good. So I will set Sandbox here as a startup project and hit F5, and then hopefully everything will work fine. Now, the first time it seems that this kind of copy step fails because the directory doesn't actually exist yet. So we'll just hit F5 again, and that should work. You can see the copying probably worked now, but now we can't open SPD log because no such file exists. I believe that's coming from Sandbox app. So it's probably because we messed up an include directory that's specific to our actual Sandbox project. So let's take a look here. So project name, vendor. Yeah, so that's not going to work because this is actually under Hazel. So Hazel vendor SPD log include should be good. So now let's regenerate our projects. We'll just double click this file, done. reload, F5, and you can see that that worked. There we go, all done. And obviously the DLL copying is working. So if we go to bin, debug, and then, Sandbox, we can see that DLL file gets placed alongside our exe file, and that everything just generally seems to work pretty well. So you should now be able to just run that file. I'll kind of run this Premake script and actually have this generate make files or Xcode project files, and everything should be great. So that's it. That's a basic kind of introduction to Premake, and we've set up Premake to work for Hazel and for Sandbox, and basically for our entire Hazel project. So I hope you guys enjoyed that. If you did, you can hit the like button below. And now this will be used, we'll kind of work on this Premake script throughout the course of this series because it's going to be our main kind of project generator. And I think there's even a way for it to generate actual CMake files if we really need that. So it's just a really good system that's really straightforward, easy to use, and that's one of the reasons that I've kind of chosen this. I want to give a huge thank you to all the patrons that make this series possible. You can help support this series by going to patreon.com/the Cherno. You'll get videos 1 week early, as well as access to like a private development branch of this engine, in which like I've already got like, a window up and running, an event system up and running, like all of that stuff. Basically, as fast as I can, I'm developing the Hazel engine kind of privately, just so that I know what to make in these videos, and all of the kind of patrons that support at a certain tier actually get access to that. And in return also, it helps me make these videos, which is really cool. Hope you guys enjoyed this video. Next time, we're going to continue on with our Hazel engine. I don't even know what I've got planned for next time. Get excited. I'll see you then. Goodbye.